calc video. Take 130.
Oh, so Daniel, do you happen to know any ways to find the area underneath a curve?
Actually, I know this neat way called the Riemann sums. Let's take a look, Tom. Now, the Riemann sums is something you use to find the area underneath a curve using what we call tangles. Now, here's a little diagram. You've got the curve and you've got tangles drawn underneath it. You find the area of the rectangles, which will give you an approximation for the area underneath the entire curve. Now, the Riemann sums comes with two formulas, one for the left sum and then one for the right sum. We'll start with the left sum. The left sum is b minus a over n times f of x plus f of x sub 1 plus f of x sub 2 plus f of x sub 3 all the way till f of x sub n minus 1. Now, these are your y values for your function, and b minus a is the interval you're given, and n would be the number of tangles you're supposed to use, as in the tangles up here. The right sum is virtually the same, with the exception of starting from the right side. So f of x sub n, which would be your last term, plus f of x sub n minus 1, and that is all the way till your second to last term from the left side, f of x sub 2. Notice it ends at the second to last term on both sides, just at different ends of your graph. Very nifty. Now here's another nifty thing. It's an example problem we have. Now here's your function, the integral of x squared, and there's the number of tangles you're supposed to use. 0 to 6 is your interval, and you're using a left sum. So we have the formula laid out here, and all you have to do after that is some basic arithmetic, and you get your answer of 55. Isn't that easy?
That's fantastic.
Well, Tom, my traps are hurting a little bit. I don't understand this rule you're trying to show me.
Are you talking about the trapezoid rule, right?
That's the
one.
one.
Good. I'm just the man for the job. All right. The trapezoid rule is another way to approximate the area underneath the curve. It yields a slightly more accurate result than using a Riemann sum with the same number of rectangles as trapezoids. The trapezoid rule is generally used when given a set of data points rather than a specific function. So, the trapezoid rule is derived from the area of a trapezoid, which is area equals the average of the bases times the height. And so the trapezoid rule is 1/2 times the interval, so b minus a over n, the number of trapezoids, times, or 1 times the value of the first value function at the first x value, 2 times the value function at the second x value, 2 times the value function at the third, etc., until you get the last one, where the last is only, value is only multiplied by 1. Notice the first and last are only multiplied by 1, and all the middle terms are multiplied by 2. That's because if you imagine the graph of the a curve, the first and last functions, the base is only used once, while the other, the middle trapezoids connect to other ones, and so we're using 2 different trapezoids when finding the area.
Well, that's just swell.
When you're given a set of data points with an uneven interval, so let's say like the intervals are different values, or the differences in the intervals are different values, then this is the function you use, or this is the formula you use. And so we have an example of when it would be used right here. So if you're given a set of data points with the specific intervals 0 to 8, and you want to have 4 trapezoids, then you just plug it in to the equation and you get this. So you get x sub 2 minus x sub 1, which is 2, so 2 minus 0 is 2, times f of x sub 2 plus f of x sub 1, which is 4 plus 0, times, or plus x sub 3 minus x sub 2, which is 5 minus 2 is 3, and then f of x sub 2 plus f of x sub 3, which is 4 plus 13, and then it goes on and on and on, and then you get the answer.
Just some basic arithmetic again.
That's amazing.